Okay, this is term 2, week 7, chemistry AMS. I'm recording for the second time because I recorded already and there's no sound. So, it pissed me off. I forgot to turn on my mic. I think, yeah, okay, there's audio now. Before starting, I'm gonna give a shout out to the No Host group in Sabs Dubai. فشاut out to them. وخلاص let's start because أنا صراحة I want to finish fast now. Uh, but at least I have all these notes already written. This week it talks about we have alkali metals and we have noble gases. You have to memorize the properties of them, okay? And the properties are important, صراحة. If you don't know them, then you're not gonna do good. But it's very easy. It's just a few properties. We have the alkali metals which are in group one. Know that the alkali metals they are solids. They always conduct electricity. They're soft and they can be cut with a knife. They're kept under, or you could say stored under kerosene. Kerosene is an oil. Okay, kerosene is an oil. Why are they kept and stored under kerosene? Because they react vigorously with chlorine and with H2O. So that's why, for that reason, they are stored under kerosene. Not only do they react with Cl2 and H2O, but in general, they are extremely reactive. Uh, this last point, forget about it for now. I'm gonna move to noble gases. Noble gases in either in group 18, which is group 8 in the periodic table over here, this group, okay, these red elements. Uh, know that they are stable. They are stable, which you could say they're also inert, or you could say they're unreactive. These all mean the same thing. Why? Because they have 8 electrons in their outer shell, meaning they don't react. If you have 8 electrons in your outer shell, so it looks like this, you won't react or donate electrons because you already have a noble gas you already have uh, a stable electron configuration. There's no need to react with anything. So that's why we say they're unreactive, because they have 8 electrons, they're stable. Know that the larger the atomic number or the larger atomic mass in a noble gas is the higher the boiling point and the melting point. So over here, the larger the atomic number, so the more you go down in this group, the higher the boiling point and the melting point. This is what I was talking about in group 1 when I said the larger the atomic number or mass, the lower the boiling point and melting point. So for noble gases, as you go down the table, the boiling point and melting point increases. However, for Lena Crypsis, which are these alkali metals, hydrogen isn't included. In the periodic table given in the school, hydrogen isn't included. Okay, it's given up. This is where hydrogen is. Okay, uh, these ones, Lena Crypsis, these are the ones mentioned in the book. Francium is also included, but يعني, I don't know, they didn't say it in the book. You don't have to know it. بس المهم, as you go down the table for the group 1 alkali metals, the boiling point and melting point decrease. Okay, uh, yeah, that's it. Know that noble gases are monoatomic. And noble gases, what do I mean by monoatomic? And you'll always find them in nature as one. So it'll be Ne, He, Kr, Xe. These are all noble gases, by the way. Uh, you'll never find them as like He2. You'll never find them because they are noble gases. What else maybe? Yeah, that's it. عندنا كمان الisotopes. The isotopes هن they're pretty much atoms of the same element that have different masses. What does that mean? If they have different masses, that means they have different number of neutrons. Can they be atoms of the same element but have different protons? Of course not, because if it has different protons, that means it's a different element. But that's why when we say isotopes, they're atoms of the same element that have different masses because they have a different number of neutrons. What is an example? The easiest example given in the book are these hydrogen. You have H11, H12, and H13. They're all hydrogen. They're all the same element. They all have one proton, right? But the neutrons, they have different amount of neutrons. In this case, the first one, 1 minus 1 is 0. So this H has 0 neutrons. 2 minus 1 in this case is 1. So this H has 1 neutron. 3 minus 1 is 2. So this this hydrogen has 2 neutrons. So they're all the same element. They're all hydrogen, but they have different masses. This one has 1, this one has 2, this one has 3. The one that has a mass of 2 is what we call deuterium, and the one that has a mass of 3 is what we call tritium. Okay, you don't have to know the names, but they were in the book, they were mentioned, they could come. moving on, and I'm going fast because I already recorded. No, I recorded all of this. But I found out my mic was not on. Uh, Sometimes they might ask, "Hala, it wasn't in the quiz." I don't think it will come, but just in case, you can skip this, if you don't care. But just in case, for those who actually care, um, questions might come where they say 20% of Cl atoms in nature are 3717, 80% are 1735. What, and they'll say, what is the average? What is the average? Like carbon, for example, carbon has, I think, 12, 13, and let me see, uh, C6. So it has 6 protons and 13. There's also another isotope which is 6 and 12, and there's another isotope which is 6 and 14. What did chemists do? In the periodic table, you see it as C6 and 12, but they ignore all the other isotopes and they don't put it in the periodic table, they only put C612. Like over here, C6 12.011. You might ask, where did they get the 12 from? They use this formula to find the average mass. Percentage of the first one times the mass of the first one plus percentage of the second one times the mass of the second one. So let's say you have 20% are 3717 and 80% are 3517. What would the average be? It will be the first percent times the first mass, so 20% times 37, plus the second percent 80% times the second mass 35. So 20% times 37 and plus 80% times 35. 20% is 0.2, 80% is 0.8. You do your calculation, you get 35.4. So 35.4 would be the average. It has to be grams per mole, by the way. That doesn't matter. You have an AMS. But this will be the average mass. Like this, there's nothing else to explain. We can start. Which of the following are not properties of noble gases? They're saying not, pay attention, not properties of noble gases. They exist in nature as monatomic. We said that's correct. They are inert. We said it's correct because noble gases don't react. Their melting points and boiling points decrease down the group. That's wrong. We said as it goes down, the boiling point and melting point increases, not decreases. They belong to column 18, which is group 8. Yes, I showed you. They're in group 18. You see, they are highly reactive. No, I told you noble gases are unreactive. They're stable. Question 2. Which are true about ion formation? This is from last week. Energy is released when a negative ion is formed, and energy is absorbed when a positive ion is formed. Why? Because if you remember, we have the positive nucleus and we have negative electrons around it. Okay, so what do we have to do? These negative electrons, the negative is always attracted to the positive. If you want to make a positive ion, you need to lose electrons. If you want to lose electrons, that means I'm pulling away this electron. But this electron is being attracted to the nucleus. So that means I have to put in energy, I have to absorb energy to separate this electron, okay, to make it positive. How about when a negative ion is formed? If a negative ion is formed, that means you're gaining electron. Okay, what does that mean? Positive nucleus. There's already electrons around it. If I'm adding one more, it's going to quickly get attracted to the nucleus because of the attraction forces between the positive and negative. There's no need, if you want to make a negative ion, to input energy, since there's already attraction forces for the electrons. The negative electrons are already attracted to the nucleus. Okay, question 3. Which are true about electrons in an isolated atom? We said electrons, they always move randomly around the nucleus. This was from last week. Because scientists, they still didn't figure out how electrons move, so we just say they move randomly. What are true about isotopes? Isotopes have the same atomic number. They're the same element. They have the same atomic number, but they have different masses. Why? Because no, wait. They have different mass numbers. They have the same number of protons, but do they have the same number of neutrons? No. Okay, we said they have different number of neutrons. Okay, please don't make this mistake. Isotopes are very, very, very simple. Just know it's the same element. If it's the same element, means same atomic number, same number of protons. But they have different masses, so I keep different mass numbers. Question 5. What determines the chemical properties of an element? We always said it's atomic number, because atomic number gives you the protons, and the number of protons distinguishes each element from the other. Okay, so that's what distinguishes each element, the atomic number. What are common properties between Lena crypsis? These are the alkali. Is my voice? Yeah, okay. Uh, oh, it's low, huh? Wait, let me. Properties. Okay, I think this is a bit louder. Uh, what are the common properties between Lena crypsis, which are the alkali metals? I told you they all react with Cl2 and they all react with H2O. Okay, they are all soft enough to be cut with a knife, and they are all always kept under kerosene. Are they shiny when kept underwater? You can't keep it underwater if we're saying it reacts with water. Yani, obviously, you know what I mean. Question 7. Well, which of the following have a stable electron arrangement? Stable electron arrangement means they're talking about noble, noble gases. Okay, noble gases. What are the noble gases? You have to get your periodic table. He, is it there? Yes. Kr, let's check. Well, let's check. Al. Al is over here in group 3, I think. Yes, it's here. That's not a noble gas, it's in group 3. So, not Al. Krypton, let's check krypton. Kr, it's a noble gas. Ne, neon. Ne is over here, it's a noble gas. Oxygen, that's in group 6, I think. Yeah, it's not a noble gas. So you just take the noble gases. Question 8. Which of the following atoms is unreactive monoatomic gas that has an atomic number equal to 2? Okay, أول شيء, these are all alkali metals. Li, Cs, and K, they're all alkali metals, so they're all reactive. Okay, so obviously it's wrong. He is a noble gas, so it's unreactive. But they said that the atomic number is equal to 2, so just make sure the one you're taking has an atomic number equal to 2. In this case, He has an atomic number equal to 2. Okay, you need the periodic table for these questions. Question 9. The mass of a proton is equal to the mass of a neutron. This was from last week. Which one is 1 divided by 1840? An electron. Okay, that's why we say that the mass of the atom comes from the protons and neutrons, because the mass of an electron is too small. Question 10. An example of a gaseous element at RTP is F2. Okay, the other choices were Br and Hg. Br is bromine, or bromine, whatever you want to call it. Hg is mercury. Okay, these are the only two elements in the periodic table that are liquid at RTP. These are the only ones that are liquid. So anything other than Br and Hg is not a liquid. It could be solid or it could be gas. Okay, please remember this. Mercury and bromine. 11. Metals are ductile, shiny, and electrical conductors. I think everybody knows this. Ductile meaning you can change it into wires. You know that most wires are actually made out of copper, which is a transition metal. Cu over here. Cu. I can't find it. Cu. Where is it? Cu. Okay, I can't find copper. Uh, how معقولة? Here, Cu copper. It's a transition metal, uh, and that is ductile because it can be made into wires. Most wires and most charger cables are actually made out of copper. It's shiny. You guys know metals are shiny, and you know they obviously conduct electricity. The elements inserted between columns 2 and 13 in the periodic table, what are they? They form colored compounds, and more than one charged ion are called transition metals. Let's look at them. Between 2 and 13. This is 13, this is 2. What's in between them? These are what we said are called transition metals. Okay, question 13. Ne, Ar, Kr, Xe, and Rn are called noble gases. Everybody knows these, knows this. They have a stable electron arrangement. Everybody knows it's stable because it has 8 electrons in the last shell. They form under certain conditions extremely reactive compounds. You're gonna tell me, طب Walid, didn't you say noble gases are unreactive? I know, but they're saying under certain conditions, and they're talking about NEAR, KR, and XE, and also RN. If you go to the book, if you go to the book, يعني if it loads, uh, down here, if you go to neon, argon, krypton, xenon, radon, which are NEAR, KR, XE, RN, under certain conditions, they are extremely reactive. Okay, under certain conditions, they are extremely reactive. After they react, they go back to normal. That's what they said, because scientists haven't been able to actually capture these five gases uh, and put them in a stable condition unless they react. So always know that neon, argon, krypton, xenon, and radon are extremely reactive under certain conditions, but they still are always stable. After they react, they become stable. Okay, question 14. Oof, there's still not. NaCl. Oh, okay, this. Okay. If you were to take Na, it's an alkali metal, group 1. We said the alkali metals, they react with Cl2 and H2O. You know, Na will react with chlorine. You know, Na plus Cl gets you NaCl. Na is plus and Cl is minus. I know, I'm sure everybody has these charges already. No. Right now, Na, if you look at the periodic table, it's number 11. Uh, that means it has 11 electrons. But once it becomes positive, it means it lost one, right? It lost one, and it became 10 electrons. I think everybody remembers this. Na, you have 3 down, no, 3? 3 down and 11 up. It has 3 no, no, what am I saying? Na has 11 down and 23 up. Remember we said 11 electrons, but since it's plus, it's losing one, so it becomes 10 electrons. Okay, Cl minus had Cl17 and 35.5. It had 17 electrons, but now it gained one electron. So it became 18 electrons. Why am I saying all of this? If you look in the periodic table, Cl, what's beside it? Argon, right? 18. So Cl, once it reacts with Na, what happens to it? It becomes the same charge as its neighboring element in the periodic table. And Na, it now has 10 electrons. What comes before Na? Ne, which has 10 electrons. All of this is for me to try and show you. Sodium will lose one electron, chlorine will gain one electron, and NaCl is very stable because it's built up of charged particles that now have a noble gas configuration. Why? Because we said Na lost an electron, it became 10. Like who? Well, let me erase this. Let me erase all of this. Na lost, it was 11. It lost one, it became 10. Now it's 10. 10 like who? Like the neon, which is a noble gas. How about Cl? We said it gained one. Now it became like argon, which is also a noble gas. So now we have 10 electrons, 18 electrons. Noble gas, noble gas. So that means NaCl, the compound, after it reacts, it becomes stable. So after an alkali metal reacts, it will become stable. Always keep that in your head, okay? NaCl is a very stable ionic crystal because after it reacts, it's built up of charged particles that now have a noble gas configuration. Why? Because you said sodium will lose one electron while chlorine will gain one electron. This will become like neon, this will become like argon, okay? Which are both noble gases. Question 15, okay, you have X, A, Z. The letter A, you know, is the mass number, Z is the atomic number. In this case, what is the protons? 35, because that's the atomic number. What's the neutrons? It's always 80 minus 35, which is 45. The electrons is, since it's an atom, the electrons will be equal to the protons, so 35, 35. Okay, it's not charged, because you know all atoms are neutral. Uh, Cl1735, let's start with the neutrons. 35 minus 17, 18. 27 minus 13, 14. 23 minus 11, 12. 32 minus 16, 16. Protons are always 17, 13, 11, 16. 17, 13, 11, 16. Electrons, you have to check whether it's charged or not. Since it's minus, that means it gained 1. So 17 plus 1 becomes 18. Since it's 3 plus, it lost 3. So 13 minus 3 becomes 10. And A plus means it lost 1. So 11 minus 1, it's 10. 2 minus means it gained 2. So 16 plus 2, 18. Easy. Question 17. Which one are atoms? Remember, atoms are all neutral. They're all neutral. So you have to look at the ones which are neutral. The first one's obviously neutral. 1, 1, they cancel. The second one is also neutral because 1 proton, 1 electron. Neutrons don't have a charge, so you cancel those out. So this is also neutral. P has no electrons. This is going to be positive. Since there's no electrons, it's only positive. This one has 1 proton but 2 electrons. So obviously it will be negative since there's more electrons. This one has 2 electrons and 2 protons. So obviously this will be also an atom since it's neutral. Okay, choose the diagram. So A, B, and E. Choose the diagram that represents a positive ion. We said it's C because there's no electrons. And choose the one that represents a negative ion. We said it's D because there's 2 electrons and 1 proton. Question 18. The number of protons in an atom is represented by its atomic number. And which one has an atomic number 2? You just look for the one which has 2 protons. Okay, the rest have 1 proton. This is also 1 proton. This is also 1 proton. Okay, this is fairly easy, صراحة. All from last week. Question 19. The mass number indicates the number of protons and neutrons. That's the mass number. Which one has X12? It's the one which has, first you have to locate how many protons, how many neutrons. Obviously, protons will be protons equals 1. How about the neutrons? Neutrons will be 2 minus 1, which is also 1. So you need to look for the one that has 1 proton, 1 neutron, and it's going to be this one. Okay. Question 20. Isotopes are defined as atoms of the same. I'm going to put my answer because this answer is wrong. Isotopes are defined as atoms of the same element. Atoms of the same element that have the same atomic number but different mass. In this case, the isotope H11, you have to locate protons is 1. How about the neutrons? It's 1 minus 1, which is 0. So obviously it's going to be this one. It has 1 proton, 0 neutrons, and an electron. But in the quiz, they gave you this answer. This is wrong because there's 1 neutron here. How is that correct? Now we said there's 0 neutrons. This is wrong. Okay, the answer in the quiz is wrong. It should be this one over here. Okay. Question 21. The nucleus is positive because it contains positive charged particles called protons and neutral particles called neutrons. Everybody knows this. 22. An atom becomes negative if it gains electrons and it becomes positive if it loses electrons. Again, yeah, simple. Okay, this one, memorize it. Protons and neutrons are made up of quarks. A quark is a very small particle that make up the protons and the neutrons. Question 24. Which two elements are liquid at RTP? I told you it's always mercury and bromine or bromine. Okay, these two, memorize them, know them. 25. What is this called? It's a period. And what is this called? It's a group. Okay, look, a column in a periodic table is called a group, and a row in a periodic table is called a period. Okay, if you don't know this, I honestly don't know what to tell you. Memorize it. Okay, yeah, you could also say row, you could also say column, whatever you want, whatever you're comfortable with. Question 26. You guys know the metals are always on the left, and non-metals are on the right. Don't say gases. Please don't say gases. Okay, say non-metals. Question 27. This one. Okay. Choose the heavier gas. They gave you two velocities, this one and this one. The heavier gas will always be the one with the lower V, or the lower velocity. So gas X has the lower velocity, so that's going to be the heavier one. And then they ask for what's the molar mass of gas X. You have to use the formula V1 over V2 equals radical M2 over M1. Okay, V1 over V2, Anna, our chemistry teacher, tells us to keep the lighter gas on top because it's easier to solve like that. And Anna also, I like solving like that. The lighter gas will always be the faster one, with the bigger one, which is 0.87, over the second velocity, which is 0.63, equals radical M2. So the molar mass of V2, do we know the molar mass of 0.63? It's X, we don't know it, right? Over the molar mass of the first one, so 0.87, what's the molar mass of it? It's hydrogen chloride, which is HCl. H is 1, Cl is 35.5, so it becomes 36.5. That's the molar mass. Okay, so you put 36.5. How do you do this? You have to square the left side and square the right side. Why? So I can get rid of this radical. I can't solve with the radical. It's ugly. You never want it. So you'll be left with 0.87 over 0.63 squared equals x over 36.5. So you have to square this. On your calculator, do it. You get a fraction. My calculator isn't like that. 0.87 divided by 0.63. Okay, square it. You get this. You get 1.9, whatever. And that answer, you just multiply it by 36.5, or whatever number you have, times 36.5, and you get 69.6, which is over here also, 69.6. Part B, drag and drop to arrange them in increasing order of diffusion. Increasing order of diffusion, يعني slowest to fastest. CO2 has a molar mass of 44, I think 16, 18, 60, 32 plus 12, yeah, 44. HCl has 36.5, which we found, and H2O has 18. I think all of you guys are capable of finding these molar masses by yourself. بس المهم, the one with the smaller molar mass, the lighter gas, is always the fastest one. So that's why we put it over here. It's bigger than HCl, which is bigger than CO2. Okay, what is the phenomenon for the two separate gases to collide with each other? So what is the phenomenon called where they spread out? I think you guys all know it's diffusion. And which one's the lighter gas? It will obviously be gas A. Since they met over here, they met closer to gas B. So that means gas A reached here before gas B could reach here. Okay. Uh, what does that mean? Gas A is obviously faster than gas B, and it's obviously lighter. Question 28. PV equals nRT. We'll do this fast. يعني. Always know P1 V1 equals nRT1, and you get P2 V2 equals nRT2. Okay, cancel n with n because we didn't talk about it in the question. R with R, you always cancel it, but the rest is all given. Nothing is kept constant. P1 is 50, V1 is 6, actually, sorry, 6. Uh, T1 is 177 Celsius, but you need to change it to Kelvin, so do plus 273. You get 450 over 50 times 6, P2 V2, which is pressure 2, 100 times V2 over T2, which is 627 Celsius, but you need to make it Kelvin. If I do plus 273, you get 900. You cross multiply, and you're going to end up with 6. That's it for this week. Thank you so much for watching, and I'm sorry for uploading late. يلا, bye. Good luck. Inshallah you do well.